All right, so throughout lesson 5, we're going to look at Boolean expressions, and we're also going to look at conditional statements. Now in this first video, we're going to focus on the different control types really quickly, just refresh our memory on those different flows of control in programming, and then from there we'll focus on Boolean statements, and then the next video will focus on conditionals as well. So just to refresh your memory, you should have learned this in a previous course, but flowcharts are graphical representations of an algorithm that we're writing in computer science, and you can see all the flows of action that are taking place in that program used by arrows and symbols. So we have 3 different types of common control structures that we use in programming. One is called sequential, one is called selection, and one is called repetition. And we'll touch on those real quickly before we jump into more complex programming. So most of the programs you've done in my class so far have been entirely sequential, which means linear, and it has one flow. So these are the very, very basic programs that just have the statements all listed in a row. So it's statement 1, statement 2, statement 3, and it does each one at a time all the way through. And you can see from the picture here that the flow of the program just goes from one instruction to the next instruction, to the next instruction, to the next instruction, and when it gets to the end of that program, it stops. That's what's called sequential. It goes one at a time in a linear flow, and you just do one instruction after the other. And these are the most basic programs that everyone starts off with to understand how computers follow that set of instructions in order from top to bottom. So that's your sequential flow. Then from here, you have what's called a selection. So you have decisions that you can make in your program, and these are when we're dealing with things like conditionals. So you see an if-then statement, or an if-else statement, or an if, else, etc., etc. So these are the statements that you'll see where a decision is made and you only run one piece of code. And you can see that over here. Essentially what's happening is this is an example of a decision. And these diamond boxes where you can pop out 2 ways in a flowchart, these are representing a sort of decision that is being made. So we'll say, for example, maybe there's a question in here. So really there's a question in there. And if the question answer is true, it goes this way. And if the question answer is false, it runs this way. And essentially it only runs one of these 2 sections of code. It won't run both. So it'll get to this point where it makes a decision. It'll choose which way to go. And after it runs the code based on the decision, it'll continue on in the order of linear programming. So it'll keep going down in a linear fashion, but there can be decisions that basically based on the answer to a particular question or a particular statement, it'll determine which way that program goes. Will it run this piece of code or this piece of code depending on the answer of the user that is using their program. So you'll commonly see this when you have conditionals, and again, those are your if-else statements, or you have more else's if you have else-ifs included in your program. Then the third type of control structure that you will see is a repetition or looping, where you are repeating a specific part of code based on a decision. So you can see here that you'd be running through your code, running through your code, running through your code. You get to this decision part right here, and this decision is basically making a decision of whether or not it's going to loop back and run that code again. And so basically, there's 2 options. There's an option where that loop is false and it continues this way, or there's an option where this loop is true and it'll loop back up and run the code again. And if it's still true, loop back up, run the code again. If it's still true, loop back up, run that code again continuously until it is false and it pops out of the loop. Now, we won't use this a whole lot, partially because in game design, there is this built-in game loop that automatically structures our game to be a repetitive loop that is constantly repeating sections of code. So you have the update and the draw method that, remember, are repeated 60 times per second. So we won't actually code a lot of loops simply because this is an automatic part of game design. It is constantly looping over and over and over and over and over again at a rate of 60 times per second. So update and draw are constantly relooping. So we need to write our program with that control structure in mind, that it's going to repeat something over and over and over again. So we have to prepare for that game loop, and we're basically preparing for changes in our program and making sure our program responds correctly to any of those changes. All right, so this next chunk we're going to refresh our memories on Boolean expressions. And remember, a Boolean variable is evaluating whether a variable is in fact true or false. So if you see something called a Boolean expression, basically it's an expression that will evaluate to be a true statement or a false statement. That word Boolean tells you true or false. So when on the previous slides I talked about an area where you would have to make a decision in code, that's what's happening, is there's some sort of Boolean statement, and if you're making that decision will either be something that is true or something that is false. You'll have a question in that diamond-shaped box, and if it's true, you'll do one thing, and if it's false, you'll do another thing. And you'll see that we'll use various comparison operators that are on the next slide to create these Boolean expressions where we are checking if something is true or false. All right, so you can see all of our relational operators here. Most of them work exactly how you would expect. However, because of the constraints of a keyboard, we can't always write them in the way that we did in algebra. So here you can see that we have all of our algebra operators that we use in Algebra 1. So we have the equal sign, the not equal sign, the greater than, less than, greater than or equal, less than or equal to. So those are our relational operators that allow us to compare two pieces of information. Is this equal to this? Yes or no. Is this greater than this? Yes or no. Now, a couple of things to keep in mind, and you can see these as you move over into the next row. You can see I kind of paired up the algebra representation with how we represent these in C#. So the first thing to notice is, and this is different depending on the programming experience that you have, if you're comparing equality, if you want to check if two things are equal, you use a double equal sign. So we've already talked about the fact that a single equal sign is talking about assignment. So we can't use a single equal sign when we're dealing with a Boolean expression. So if you see a double equal sign, this is where you're checking, okay, is this equal? Are these things on both sides of the equation equal? So you can see an example here on the first line. What this statement is saying is 3 times x, whatever x is 3 times x equal to 15? It's asking that question, and then you would either answer true or false. So double equals is checking for, are both sides of this statement true? Then not equal sign, we don't really have an equal sign with a slash through it on our keyboard, so we do not equals by using this exclamation point here. So what this statement is saying is it's checking to see if something is not equal. And that exclamation point essentially is the word not. So if you look at that statement on the second line in the third column right here, this is checking to see, is y not equal to w? And if y is anything else but what w is, that statement will return true. However, if y and w are the same thing, that statement will return false. Now, if you go to those next two rows, you'll see that these two rows work exactly as you would expect. You have the greater than sign and the less than sign, and those are checking, is one side greater than the other, or is one side less than the other? Then the next two rows, to represent greater than or equal to or less than or equal to, because we don't have these symbols with the equal to part on our keyboard, we do this by including the equal sign after. So this is saying greater than or equal to for here, and less than or equal to here. So remember, all of these statements will evaluate to be true or false. Your computer is checking, is this statement, is this expression true, or is this statement false? So keep that in mind. This is not math. We are not finding the value of the variable. We are checking, based on that variable value, is this statement true? And if so, run this piece of code. And is this statement false? If so, run this piece of code. So what I would like you to do on this slide is I would like you to take the time to use the values of x, y, and z given above, and to tell me whether or not these 8 statements will result in a statement that is true or will result in a statement that is in fact false. So work slowly through these, use your order of operations, double check those relational operators, keep in mind what the modulus sign means because you can see that in there. A couple of things to pay close attention to, really think through, what does this sign right here mean? Same thing for number 7. What do these actually mean in computer science, and how is that going to affect your final answer? So you're going to evaluate each statement, pretending that you are a computer, reading that statement, decide whether that statement is true or false, and then you can move to the next slide and check your answers. All right, so again, use this time to check your answers here. Check, okay, how did I do? Is this Did I get false for this one? Did I get true for this one? And if you are struggling, this is another excellent time to ask a clarifying question. So make sure you've got your knowledge of Boolean statements down, because we will be using Boolean statements quite often in game design. They are how we make choices. They are how we check for changes in our game. So if you don't understand how Boolean statements work, this is a really good time to double check and ask a question. If you are good to go, then you are ready to move on to the next video concerning conditionals.